How's everyone doing this morning?
Good. Too hot. It's too warm. It's too warm.
Already?
I'm not used to it, so.
It's not going to get better, you know that.
I don't want to stay in Bordeaux.
What's going on?
You need to buy an aircon. Air conditioning.
Air conditioning. No, I want to resist.
Terrible idea.
Preuve que ma vie existe.
Terrible idea. Let's see how long you resist.
Yeah. I can go to my swimming pool.
Well, it was nice talking you. That's not working today. Let's do this. Okay. Here we go. Podcast just came back on. Right, everyone here, including our presenter. Fantastic. Welcome to Neuroccino on this Monday morning. Today we have a paper presentation by Merve on stroke. And the rules of the game is you come present a paper or a book that you read and got excited about, and you let us know why you're excited about it. This is the second to last Neuroccino before the summer break. So thanks for joining us today. And remember that next week we have Meet the Editor. And I'm going to come back to that later on. But for now, Merve, if you want to share your screen and present your paper, that'd be great.
Of course, I will. Thank you very much, Steph. Okay, now you see, I guess.
Yes, can you zoom in so it's the full page, please?
Full page.
Just increase the zoom a little bit.
Okay.
There we go.
Maybe it's better. Okay.
Great. Thank you.
Okay. So I start. Again, good morning, everyone. Okay. All of you know each other, but maybe I just briefly for 1 minute, I should introduce myself. I'm working as an assistant professor of neuropsychology, and I'm most interested in memory decline, aging, and dementia, and their neural correlates, of course. And as far as I understand, I know your focus of interest is about stroke. So I thought it could be nice to find an article which meets my personal interests and the scope of your common work. I'm sorry, your scope of work on the same ground. That's why I wanted to find something related to cognitive decline and the stroke outcomes. So the article that I want to discuss today is the interaction between cognitive reserve and age moderates effect of lesion load on stroke outcome. So now, all of you see the PDF, right? I guess I should, how can I move it? Let me see. Okay. So this is a relatively novel paper, which was published this year. And it starts with briefly mentioning the concept of cognitive reserve, which is a relatively novel concept in literature, in fact. You know, we have a brain reserve, which is all about the structural properties of the brain, the number of the neurons, number of the synapses, etc., the volume of the brain, etc. On the other hand, cognitive reserve can be defined as the capacity to use that brain, to use that structural reserve in order to perform our cognitive functions. And in case of any neural loss, it might be because of anything, normal aging, neurodegenerative disorders, or stroke, just like in this case. So to cope with, to compensate the neural loss that we can ever experience. So, and in this paper, researchers wanted to explore the post-stroke protective impact of cognitive reserve. In fact, I mean the interaction, or let me put it this way, they explored the interaction between brain reserve, cognitive reserve, and the stroke characteristics. So let me go to the, so this is their hypothesis in general. So it is not surprising, or it is not a kind of discovery, to find that, yeah, age affects negatively anything related to brain, and education has a positive effect to any brain damage. We are sure about that, but their hypothesis is the fact that there is an interaction between all of those factors, which eventually affects the cognitive decline, stroke-dependent cognitive decline. So, so let me continue. So they included more than 100 patients who experienced a stroke in the chronic phase. They used MoCA to measure cognitive decline. They used NIH stroke scale and modified ranking scale. I don't know, it must be something which measures the stroke-related disabilities, I guess, motor disabilities, I don't know. They used age as a measure of, as a proxy of brain, the brain reserve. They used education as a proxy for cognitive reserve. And they used the stroke lesion size as a measure for, stroke severity. And they checked the interaction between all of them. So let me skip to the findings. I'm going to show you the, yeah, here. The first interesting and, surprising finding of the study is the clear interaction, clear modification of age and education on cognitive decline, on lesion-related cognitive decline. So if you focus on the picture here, on the figure, you'll see that, for example, if you are young, and if you have a big lesion, but if you are well educated, the lesion size does not significantly increase your cognitive decline after stroke. So higher education decreases the possibility of a more severe cognitive decline if you are young. So age and education interacts with the lesion size. And if you, again, check the old age figure, which is the third one, here you see that if you are an elderly and you have a small lesion, but you are undereducated, then a small lesion can result in a cognitive decline to an extent of a big lesion. So lesion size, you see here in elderly, the lesion size creates a serious cognitive decline if you are not well educated. But as your education level increases, in the small lesion size, the stroke-related cognitive decline can be highly attenuated due to the protective effect of education. So there are some things on chat.
Don't worry about the chat for now. We come back to it.
Okay. Yeah, better education, better performance on cognitive tasks. Yeah. The same correlation exists before stroke. Wow, good question. Well, most probably, but I think since they involve the lesion size as another moderator, so I mean, what they found is a three-way interaction, not only a relationship between age and cognitive performance, or education and cognitive performance. They made a three-way analysis to put all of those factors as different variables, which can affect the cognitive outcome at the end. So also, in addition to the cognitive decline, they also measured, they also tested the stroke-related disability, whether, the stroke-related disability is moderated by age and education as well. And the results were almost the same. If I can skip to why I can't. Oops. It doesn't go. Yeah. I guess here you can see, for example, NIH stroke scale, which measures a disability of stroke. I'm not sure what it exactly measures, but so here you see, especially for elderly, higher education results in a in a milder score in NIHSS. So both in the acute and the chronic phase. Also, the results are similar for the other stroke scale as well, especially for elderly, for example. Here you see the motor functions, are less affected in elderly if they are well educated. So these are the findings of the study. So I chose this article, as I said, both because it meets both of our interests on a shared ground, and it successfully interprets the findings. Maybe the findings, if you just how to say that, if you evaluate the findings one by one, it might not surprise you. Yes, age. If you are older, the lesion size might affect you in a more significant way. Or if you are less educated, yeah, of course, your brain is more vulnerable to any lesion, etc. But the interaction between them, their ability to modify the outcome of the stroke lesion depending on the stroke lesion size. So all that three-way interaction, I think it is worth mentioning. Yeah, but of course, I want to mention some limitations. They used only education as a measure of cognitive reserve. We all know that cognitive reserve does not equal to education. Cognitive reserve is a kind of umbrella which is affected by many factors, multiple factors. Yes, maybe the most important contributor is education. Yeah, but it is not only education. Education level, profession level, leisure activities, IQ, all of them are important factors which create at the end cognitive reserve. So only to measure education as a proxy of cognitive reserve, I think, is the major limitation of this study. They could, I don't know, involve a cognitive reserve scale. In fact, last year I even published an article about that. I made a standardization study for Turkish language, of course. But there are many, so they could use a cognitive reserve scale to, properly measure cognitive reserve, which decreases, I think, the validity of the study. And it would be very nice if we could see the structural and functional connectivities of those patients, right? So again, there are some time. Yeah, baseline severity.
We come to the questions in the chat when we do discussion.
Okay,
don't worry about it.
Yeah, just, it's my first time. That's right. Yeah, what I was saying was that it would be astonishing to have their structural and functional connectivity findings, because when I heard about the concept of cognitive reserve for the first time, I always thought that functional connectivity might be the real biomarker for cognitive reserve, in fact, because it is how we use our brain, how different regions are well connected or not connected, to each other. So I think and there are some papers, if you check the literature, there are some papers which regard functional connectivity in certain regions. I mean, the connectivity between certain regions, they regard this connectivity as a biomarker of cognitive reserve. On the other hand, structural connectivity might be our brain reserve. So it would be very nice if we could have these findings with the brain correlates. So yeah. Now I guess we can check the chat box.
Lovely. Thank you so much.
Thank you. Thank you very much for your listening. I know this is a very light paper as compared to those that you discuss in general, but I wanted to just find something related to cognitive decline and stroke, and this took my attention. So I just wanted to share those findings. Maybe it might be helpful to, I don't know, recruit patients to your I don't know, MRI studies, maybe the age and education, the moderator effect.
A very, very interesting paper indeed. And I got plenty of questions for it.
Oh my God.
But I can see there's already hands up in the air.
Yeah.
So Patrick, do you want to kick us off with the questions?
I think Leah was first, though. So, all right.
Sorry, I was going by the rule of external first, internal later.
All right. Thanks a lot. So yeah, Merve, is it right?
Yeah.
Thanks a lot. Really, really cool paper and brilliant presentation of the paper.
Thank you.
So it kind of makes me wonder, like, what really the impact of education, or we discussed in this chat, like other factors such as socioeconomic status, but what the impact of these experiential factors are on brain structure, or on the structural correlates of what has been called cognitive loading, or not loading, but these cognitive reserves, sorry. So you already mentioned it could be something like structural connectivity, functional connectivity. Could you potentially just discuss this in a bit more detail? Like, what would that actually mean with regards to lesion size? Because lesion size would also, like, bigger lesion size should severe more strongly more connections, right?
Yeah, exactly. But I mean, cognitive reserve that's why very important recently, because it helps you to compensate the neural loss in the brain. So if you have a higher education, if you you spend your time with a more kind of intellectual activities, let me say, if you engage more in intellectual activities, etc., and it helps you. I mean, cognitive reserve is mostly studied in fact, studies with dementia. So for the first time, I saw something related to stroke, but that's why maybe I was interested. I was surprised because there is a big lesion in the brain. So there is a damage. There's a structural damage in the brain, which definitely, affects your brain reserve in a negative way. But if you have a higher cognitive reserve, in this paper, I wouldn't prefer to call it cognitive reserve, as I said. If you are higher, I mean, if you are well educated, let me say. It really modifies how you use your brain, which is left to you, let me say, after the stroke. I mean, regarding the connectivities, I have read some articles where, I mean, they say stronger cognitive reserve increases the connectivity between certain brain regions. But if we talk about structural connectivity, it is not cognitive reserve already. So I don't know, I could be able to answer the question, but I mean, in terms of the brain, they say it increases the connectivity, but we don't see it in this paper.
Yeah. I mean,
so,
but couldn't it also just be that people with higher education tend to have some personality traits that make them stay longer in education,
yes,
potentially
exactly.
indicating like they like to suffer a little more,
exactly,
like to,
exactly.
you know what I mean? Like they keep on it a bit more, like being more motivated, and that could also have an effect on their like compensational compensatory mechanisms or effects.
Yes, exactly. But this is also a part of cognitive reserve, what you talk about, I think, according to my understanding of cognitive reserve. I mean, you have that intellectual capacity, and your brain is wired such that until that point, let me say, and that's why you are more able to compensate the loss. I mean, it is a kind of cognitive reserve.
I think one of the problems stems from the fact that cognitive reserve was discovered basically just by observation. In the 80s, they saw that people with higher education were affected by dementia later in their life. So they just say, okay, so there is something there, and we will call it cognitive reserve, but I don't think it's fully understood what exactly it is, and that is one of the problems. For me, well, something that could explain it would be basically that you are training your neurons to work in a better way, better way with the quotation marks, right? But more effectively. So you've got maybe your pathways sorted up better. Or I don't know exactly how it would work, but it would not be super structural. More like you've got things. For the lack of a better term, like with a better organization in your brain, but it's basically the same structural organization. And so you can use your brain better when it starts to break down, and maybe you can come up with strategies to circumvent the cognitive problems that you might have because of structural damage, up to a point. And this is interesting in the paper because you see that the brain lesion, when you compare to the size of brain lesion and the effect on cognitive evaluation with regard to the education, you can see that you've got the same kind of trend that you have in dementia, basically for small damage, which could be you can do the parallel with the early stage of dementia. You have much better results for the higher educated people. And then as you move to bigger damage, so larger stroke, lesions, or here it's not explored, but for later stage in dementia, you can see that the both of the cognitive problems converge either for lower or higher educated people. So I think the article makes sense, and it does not explore more what is exactly the fundamental about the cognitive reserve, but interesting stuff.
Sorry to interrupt once more, but because Leah is already waiting for asking a question, but I wanted to add something to Victor or ask something about that, because here's the thing, like that makes me wonder. When we say more efficiency, right? It kind of implies that less resource or less neural tissue is actually needed in order to compute a certain function. Hence, if you have a bigger lesion, then that should still potentially make more in your brain, decrease your functionality or your functional level even more if you have a very sparse neural correlate for certain functions, right?
Well, it depends if it's as you said, like you use less neurons for the same thing, you'd have like more special, what you say, like you'd have more specialized part of your brain for one specific thing, and so if you break it, you lose everything. I don't think it's the case in these parts here, and as you can see, it's not what's happening. So it's more, I think, about the it's a complicated topic, but this is why I talked about what did I say? You can have strategies. Basically, you come up with strategies to solve problems. So
which is the definition of cognitive reserve.
Oh, it is
cognitive reserve. Yeah.
Okay. All right.
I mean, you have your shortcuts. You have your strategies to use your brain. I mean, to perform your cognitive function.
That's coping strategies, which will also potentially be linked to socioeconomic background and education again. So it's kind of a circular argument. But I just wanted to throw in some food for thought here, because the relationship between lesion size and clinical presentation is not necessarily linear, and it's not a matter of the bigger the lesion, the more deficits you have. So it could also be that you have a tiny lesion, but it just knocked out a very essential part of the brain and has a big impact. Just boom, discuss.
So
yeah, but it was my question.
But I wanted to mention, I mean, just Victor shortly mentioned, but how cognitive reserve came to existence. There were people who passed away as having normal cognition, quote unquote. But when the researchers made an autopsy to their brain, they realized that they have the pathology which is consistent with advanced level of Alzheimer's disease, not even the beginning level.
So, are we talking general, or do you think of a specific person at the moment?
I'm talking about people who passed away. They had dementia. Okay. They had dementia. I mean, cognitive reserve was discovered like that. I mean, so researchers discovered, they generated this concept of cognitive reserve as a result. When they realized that they were cognitively normal people, as I said, quote unquote, but they had advanced level of dementia, in fact. So then they said, okay, these people lost their brain reserve, but there should be something else which compensates that loss. And as a result, this concept emerged. So Michelle wrote something. Sorry, I missed those. To assess properly, to assess the cognitive reserve, you mean 2 points, 2 time points?
Hang on.
If you have 2 time points, you'll be able to control for other variables, such as, for example, whether people different related to the education of the age before the lesion. If you have 2 time points, you can actually look at the dynamic of the recovery. So if they did like acquire those behavioral data at the acute and the chronic stage, you'll be able to have stronger results and stronger conclusions.
Yeah, exactly. I got your point. But in fact, in the paper, they made a kind of pair match to eliminate the gender effect and, to match the people who have the same level of lesion size, etc. But yeah, it is not the point that you mentioned exactly.
There's a huge confounding variable, which is, like the starting point is different. And you can match anything you want. They're different.
It's what Steffi hinted at in the chat when she wrote it's the baseline, right? I mean, if you're just better with your cognitive reserve, whatever that is again, right? It's good to have more of it. We don't know what it is, but it's good to have more of it.
Yeah, exactly. Good definition.
Nice summary. I don't know what it is, but I want more.
Probably just sorry, to bring up your point, Steffi, again, your food for thought. This actually implies, this paper, that people with higher education, higher cognitive reserve have potentially a stronger distribution of functions. Thus, so within the cognitive network or within our brains. Thus, one spatially defined or focal lesion doesn't have too much impact because the network for a given cognitive function is just so distributed and potentially less dependent on single players, single big nodes within the network. Obviously, it kind of depends still on where the lesion exactly is, right? But still, would that imply that? What do you think?
Yeah, it makes sense because I mean, this is already the myth of cognitive reserve. I mean, if there's a damage in a specific part, in a specific single location, for example, the other brain areas can take the role of that impaired region and compensate the loss. So, which means then those functions are more distributed to other parts of the brain. So, and if a region is impaired, the other one takes the role. That part is impaired, okay, it is connected somewhere else. So it works in a more coherent way. It is not that easy as I say, but yeah, I'm just exaggerating right now. So yeah, but yeah, distributed networks might be a result of a stronger cognitive reserve, whatever it is.
Again, Valentina, let me play devil's advocate very briefly before I give the floor to Valentina here. And sorry. So yes, the neuroplasticity, so after a lesion, another part of the brain might take over the function, but that's not a given, and that might also depend on the function we're talking about. So just bear that in mind, devil's advocate. Leah, your turn.
Totally agree.
To add, because it was my question actually was related to this, what we were discussing. If there were like specific regions that can be privileged by the cognitive research, maybe I was thinking like a frontal lesion, or if an hemisphere is privileged by the cognitive research. And this is something that you can test, I think, with the lesions, because we are not looking to diffusion MRI or fMRI, just looking to the lesions. This was the question.
Yeah, totally agree, but yeah, I don't have an answer to it, but yeah.
Okay, so in the paper they didn't.
Yeah, they do not mention, and but it would be perfect. Yeah.
Valentina.
All the discussion make me wonder whether lesion studies should keep on taking into account only age and education as variables, or if they should also look at the cognitive reserve, and what's the difference, what the added value of looking at the cognitive reserve index rather than age and education, like in balancing out the groups in lesion studies.
Yeah, exactly. This was what I mentioned in the last part. It is the most important handicap of the study. So they didn't measure the cognitive reserve index. Instead, they only took education into account as a proxy of cognitive reserve, which is a major limitation. So I wouldn't call, as I said before, I wouldn't call this as cognitive reserve. I would call it as just education. I would call it as what it is. So it would be perfect if they had a cognitive reserve scale. Yeah.
But according to you, lesion studies should use as should control for the cognitive reserve index.
Nice question. It would be nice. I mean, I would like to know if a stroke lesion could be affected by the cognitive reserve index.
But does such an index exist, or?
Yeah, there are many.
Okay.
There are many. I'm not many, but a couple of, let me say, cognitive reserve indexes. Yeah.
But it is a problem of definition still.
Yes, exactly. As I said, it's a relatively novel concept, and it is an abstract one. So we cannot measure it, we cannot see it. So it is, cognitive functions are always like that. So yeah, it's an abstract concept, and we have to deal with that definitions forever, it seems, if we are talking about cognition.
Well, we'll come up with good tests. Some of us do. Valentina, do you still have a question, or your hand is still up? Okay. Patrick, your question was answered?
Yeah, I don't really know. Probably not. So.
Which question? I'm sorry.
Just sorry. No. It's nothing. It's fine.
He just put his hand up and it disappeared. That's
exactly. The thing is, like, so I'm a bit confused now. Do we have a cognitive reserve index, and if so, what does it actually constitute? Because as we already discussed, like we don't really know, apparently, or at least I have no idea yet, what the absolute operationalization of this index should be. So is it a questionnaire? Does this index truly exist? Has it been operationalized by some researchers for a working definition? Because definition itself can be so broad. And just as I ask, awesome. Thanks a lot. There's something in the chat about it.
This is what I made the translation study and published last year. This is the scale, for example.
Interesting.
It's a kind of questionnaire, and it has a formula created by Nucci et al. And his friends. And yeah, I cannot deny that the most part of your score comes from the education part. Formal education and additional educations. So, but there is a leisure time activities part, there is a social activities part. I mean, and there was a professional and social activity and educational part. There were 3 parts as far as I remember. So, and at the end, it gives you an index, a score out of 130, as far as I remember again. So I can send you, I have the article already, so I can send you. But yeah, and there are some alternative questionnaires as well to this one, but I guess this is the most widely used.
So just to rephrase that, in order to increase my cognitive capacity or reserve, what things do I need to do in life? What shall we all do?
Yeah.
Depending on this question, you know.
Yeah, exactly. They say, let me say, higher education, which is apparently you have already, complex professional level, and leisure activities, which affect you in a positive way. It might be even affect you in a positive way in terms of emotional state, so leisure activities, social life, which means
what leisure activities? Just sorry there. Shall I read more books or shall I do more sport? What's more important?
You should go to the bar and etc. No, I mean in the questionnaire, for example, it asks you whether you take care of pets, whether, for example, Steph does. So, or whether, for
Not
example,
sure that's helping my cognitive reserve at the moment.
Or, for example, I don't know, you whether you manage a bank account of yourself or someone else, or how frequently do you attend to a concert, to a theater, to a cinema, etc. So these kinds of activities are questioned in the questionnaire. Those kinds of activities. So
let me dive in.
And I'm sorry, I'm sorry, Steph. Just in the social activities, for example, they even ask whether you do gardening, whether you dance. I'm trying to, remember the points in the questionnaire, but yeah, all of those activities brings you some points for your cognitive reserve accordingly.
So I just want to say that outside of the questionnaire and that study, lifelong learning is definitely a good one. So keep reading those books. And then there was this interesting study in mice where they showed that running actually helps your neuronal growth and your cognitive reserve, but only if you do it voluntarily, not if you force yourself. So I'm not entirely sure how that's going.
Interesting.
Yeah, in fact, I mean, you mentioned, a very good point, I think, because physical exercise, definitely, there is no question mark at all. It contributes to brain reserve and cognitive reserve at the same time. So there is no hesitation.
And also the social network, and I'm not talking digital social networks, I'm actually talking your social network. Will help. Let me move us on to another question if no one has a question at the moment. So I was wondering,
all of them in the chat. Did I miss anything? I'm sorry if I missed something. I don't know.
I think everything from the chat is answered, but correct me if I'm wrong. But the question I had is if in the paper they discuss therapy and rehabilitation at all, because the factors that you discussed based on their study are years of education as a proxy for cognitive reserve and brain age as a proxy for brain reserve. Both of these factors we cannot change anymore. They're fixed factors. So how would that then impact in terms of therapy and rehabilitation?
Yeah, it's a very important point, but they didn't discuss that, and they didn't include this as a kind of variable in the article. So I have no idea, but according to me, of course, a more successful or maybe longer rehabilitation process would definitely increase the cognitive outcome after this stroke. But I don't know. I mean, I've never worked in this field, I mean, rehabilitation after stroke. So I don't know. But yeah, it is an important confounding factor, as you mentioned. Yeah.
So I guess it's time for us all to start preparing our brains now and keep learning and running out of pleasure.
Yeah, exactly. A physical and intellectual activity. That's all.
Fantastic. I think that's a very good concluding remark for Neuroccino on Monday morning. Physical and mental exercise. Unless there are any questions that I ignored, but it's looking good at the moment. Fantastic. In that case, thank you all for joining us this morning, and we're excited to see you next week for Meet the Editor with Communications Biology. So do come and have all your questions ready for the editor. So it's a very great opportunity to have Carly come and talk to us in the morning. Thank you so much for presenting your first paper, Merve. Great discussion, everyone.
Thank you for your interest. Thank you very much.
Have an exciting week in science, and I see you next Monday morning. Bye.